Okay, so today what I want to talk to you about are going to be the circuits that we were doing in the lab. And I'm also going to talk, those are clipper circuits, which we also refer to as limiter circuits. So sometimes what's going to happen in electronics is we'll have a signal and the amplitude is going to be outside of what we can work with. So what we create are limiter circuits, clipper circuits, to limit the voltage between whatever values we'd like. All right. In this case, we'll say we've got a sine wave at the input. We'll make our sine wave 10 volts peak, so plus 10, minus 10 volts. So it means for half of the time, current is going in one direction, and for the other half cycle, so for 180 degrees, we go one direction. For the other 180 degrees, we change polarity and go in the other direction. So the first circuit I've got here is all I've got is a sinusoidal supply. I've got a resistor and a diode. I cannot build a circuit with just a diode by itself. I have to have a resistor in series with it to limit the current and to take up whatever other voltage drop, whatever is left over in voltage. Because the diode, when forward biased, can only drop 0.7 volts. It can't drop more than that. If you try to put 10 volts across a diode, you'll burn it out, at least forward biased. It will sustain it if it's reverse biased, but not forward biased. So we'll start off with the first 180 degrees. So the first 180 degrees, we'd be going plus, minus this way. For a resistor, I'll put something like, I'll put about a kilo ohm. Now with some students, we did some circuits, we did it with 100 kilo ohm. You can put bigger resistors, but you can expect to have lower voltage drops. When you're forward biased, your voltage drop is going to be less than 0.7. It might be like 0.4 or 0.3 if you go with a higher resistor. If you go with a lower resistor, it'd be closer to 0.7. Okay, so the first 180 degrees, what we have here is current will flow through the diode because now we're forward biased. So we have plus, minus like this. We drop 0.7 volts. The rest of the voltage, okay, is going to fall on the resistor. So if I've got 0.7 here and I had, let's see, 10 volts peak over here, well, it would only make sense that I would have 9.3 falling on that resistor. So if I drew, if I took my output over here, so let's say I take V out here. So V out. So this is the ground connection. This is where you put the tip of your oscilloscope. If this was V out, well, V out would rise up to 0.7 volts for the first 180 degrees because the diode is conducting. All right? Now for the next 180 degrees, what now happens is when the current turns around, and now the polarity is going to be plus, minus this way, the diode doesn't conduct. It doesn't let current through. So there is no current. So that means the voltage drop on this resistor is now 0 volts. So if you have a source, and the source now is going to be negative 10 because it's positive down here, negative up there. So if you have the source like that, you've got 10 volts negative, you've got 0 volts there, well, the voltage has to fall across the diode. So what you get is this. So V out's in red here. V in blue. And then the whole thing repeats itself. So then you go back to 0.7 and then negative 10 and so on. So this limiter is actually limiting the positive voltage to 0.7 volts. And that's what's going on there. If we flip the diode over, so if I turn the diode the other way around, well, the reverse happens. So if I turn the diode this way, then the output wave, do that. The output wave will become negative 0.7. Oh, hang on. So this would be positive like this, negative 0.7 like this. Is that right? So it's just the opposite when you flip the diode over. Easy enough? Any questions on this? All right, so what we'll do is we'll do like we did on the circuit in the lab, is we'll add a DC power supply now. So what I'll do is I'll change the circuit now. So put our diode facing this way. And I'll put power supply like that. So the long line is the positive, the short line is negative. Again, what I'm going to apply at the input, I'm going to have a sine wave here. The sine wave is going to be plus 10, negative 10 volts. Is that right? And just as an example here, I'll make the power supply here. So what I'll do with my DC power supply is I'll put it to, oh, I don't know, 3 volts. 3 volts DC. And I'll indicate that that's DC, just for an example. So I'll indicate what I'll do in blues. I'll indicate VN as being the blue waveform. So this is our this is VN. So this goes plus 10. This goes negative 10. So this is VN. This is blue. And we'll analyze it and see what happens. So, we'll start with the first 180 degrees. So we'll start off with this part right here, positive. All right. So we'll have plus 10, so it'll be plus negative this way, 10 volts. And current is going to flow like this. And it should flow because the diode is forward biased. All right. So it's forward biased at 0.7. All right. So if we read at a very maximum, if we read across here, well, we've got 0.7 volts plus 3. So we should be able to drop this way when our current the first 180 degrees, when the diode is conducting, we should be able to drop right up to 3.7 volts. That's the maximum we're going to drop on the output, right? Because we've got 0.7 here. And 3 here. Whenever everything is, got our maximum current, we hit our peak, we can't get any more than that across the output. Good? So now for the next 180 degrees. Out of there. So now we're going to do this part here. So the next 180, the current turns around. So this becomes positive down here, negative here. Current tries to go this way, but it can't. Correct? Because the diode blocks it. So if I have no current, what's the voltage drop on my resistor? 0 volts. All right? Now think of it this way. Let's say I've got a power supply. I got a wave here. So this is my sinusoidal wave. I've got a... And I put, I don't know, an oscilloscope here. So let's say I tie an oscilloscope right here, goes to my oscilloscope, which is just a kind of a fancy voltmeter, and there's no current that flows in and out of my oscilloscope. So if I had a circuit like this, well, I don't have a closed circuit. When you look at it, there's no closed circuit. There'd be 0 volts on here. So what I would see across here is my source. Okay, whenever I've got the source, this is what I see. Well, the same thing applies over here. This circuit, there's no current. No current can't go this way. There's no voltage drop here. So what I'm going to see when I look over here is I'm actually going to see my source. So at the output, I should see my full negative 10 volts. So what we found in the lab is by playing around with this power supply, we could play around with the level at which we would click. If I turn this around, so the next circuit after that, what we did, we'll do the same analysis. So we'll flip the diode around. So this time we'll have it going this way. And we're going to tie the negative to positive that way. So, and let's say I'll set this thing up at 4 volts. So let me draw V in again. This will be V in. Plus 10. Negative 10. So far, so good with this stuff? Not going too fast for you? So if we start with the first 180 degrees, well, first 180 degrees, we're positive up here, negative here. Current is going to try to flow, but it can't because of this diode. Diode's reverse bias. So we can't have any current flow. It means we've got no voltage drop here. So whatever we're reading here is actually the source voltage. So the first 180 degrees, this thing goes plus 10. This is your output. On the next 180 degrees, when we go negative, this goes positive like this goes negative this way, and now the diode is forward biased, plus, minus like this. It'll drop 0.7 volts. Current will flow. The diode is forward biased. And what we read across the output is going to be, well, negative 0.7, negative 4, so it'll go down to negative 4.7. So this would be plus 10 up here. And we'll clip down here at negative 4.7 volts. It's always the supply plus a 0.7 on the diode. Yes?
Why don't we add this light voltage in the forward bias? In the forward bias, like where we got the 10 volts, and why did we add the slide voltage in that?
Well, we're measuring, what we're doing here is we're measuring from here to here. So it's like having, you've got one branch over here, you've got one branch here, right? So if you would agree that if I drop 0.7 here and I drop 4 here, this would give me 4.7 from here to here, right?
And in the reverse condition,
Well, in the reverse condition, what happens, current tries to flow this way, but the diode blocks it. So there's no current. If there's no current, that means over here in the resistor, there's 0 volts dropped, right? No current in the resistor. So if I'm reading from here to here, and let's say I decide to read this branch, well, I've got 0 volts and I've got plus 10 over here. So that's how I read the plus 10. So it's exactly what drops over here from here to here. You're actually going to see plus 10 volts. You're going to see that go up to 10 volts. Okay? And some of that voltage is falling on here, the 4 volts, and 6 volts on here to make up your 10. Okay? It has to add up. Okay. Does that explain it? Yeah. Okay. Good. Okay, so that brings us to our last circuit. We're just going to analyze that. So you had the final circuit in the lab that looked like this. Okay. Okay, so on this thing we'll start with the first 180 degrees, so we'll do plus 10 this way, so positive, negative this way. So in this case, what's going to happen is current can't flow into this branch, but it will flow on this branch. So we're going to get 0.7 volts dropped, positive, negative like this. So at the output, what we should see during the positive transition, so if this is our input wave, what we should see is, let's see, plus 0.7, plus 4. So this will go up to 4.7 volts like that. And then on the next 180 degrees, current will travel in the opposite direction, negative like this, and it won't go in through this branch. This diode's reverse bias, so it can't go through here, but it will go through this branch, and we'll get plus negative 0.7 that way. So if you read, it's negative 0.7, negative 0.6, so this thing will go down to negative 6.7 volts. Okay? So I'm going to give you a couple of minutes here, and I'm going to have you figure out, if I was going to take a look on the resistor, so resistor R. So resistor right over here. 1K. What do I have for a waveform there? So I'll have you figure that out. What's my waveform on that 1K resistor?